This is the pinnacle of American naval power. A billion-dollar fleet of littoral combat ships, autonomous mine-hunting drones, and cutting-edge laser systems capable of tracking targets at the speed of light. It is, on paper, the ultimate solution to any maritime threat. Yet, at this very moment, this high-tech armada is sitting motionless just outside the Strait of Hormuz. It is effectively paralyzed. Why? Why would the most advanced military force on Earth hesitate to enter a corridor only 21 miles wide? The answer isn't just about the thousands of mines buried in the seafloor. It's about a fundamental shift in the geometry of the battlefield. While the United States spent billions perfecting the art of finding the mine, Iran spent 40 years perfecting the art of hunting the mine hunter. The Strait of Hormuz is a massive bottleneck, a geographic trap where the water is shallow and the maneuvers are tight. The moment a specialized minesweeper enters these lanes, it ceases to be a hunter and becomes a slow-moving, high-value target. From the rugged, mountainous coastline, Iranian mobile missile launchers sit hidden in fortified caves, ready to strike from miles away. On the surface, swarms of radar-evading fast-attack boats are staged to launch a 360-degree assault, overwhelming defensive systems with sheer numbers and raw aggression. It is a lethal equation. You cannot clear the floor while the roof is falling in. The Navy has the scalpels, the lasers, and the robots. But in this specific kill zone, they lack the armor. They have the technology to find the threat, but they lack the monster required to stand guard while the work is being done. They need something that doesn't just survive the fire, but thrives in it. They need a flying tank. They need the A-10 Warthog. And here is why this Cold War legend is the only weapon capable of solving the equation at Hormuz. To understand the crisis at Hormuz, we have to look at the tools we sent to solve it. Enter the Littoral Combat Ship, or LCS. It's sleek, it's fast, and it's packed with millions of dollars in sensors. On paper, it's the perfect scalpels for surgical mine clearance. But here's the kicker. To hunt mines effectively, you have to be invisible to them. That means you can't have a massive steel hull that triggers magnetic sensors. So the Navy built the LCS and its mine-hunting predecessors using non-magnetic materials like aluminum and fiberglass. It's a brilliant engineering solution for the floor of the ocean, but it creates a catastrophic vulnerability on the surface. In the world of naval warfare, aluminum has a nasty habit of melting at relatively low temperatures. Fiberglass is even worse. It's essentially a high-tech eggshell. While these ships are busy scanning the silt for a 3-foot-long steel cylinder, they are completely exposed to the most basic kinetic threats. We are talking about a $500 million ship with the structural integrity of a soda can. A single well-placed shot from a Soviet-era 23mm cannon or a cheap shoulder-fired RPG wouldn't just damage an LCS, it could effectively delete it. This is variable 1 of the equation. The Navy sent a glass cannon to do the world's most dangerous janitorial work. But the fragility of the ships is only half the problem. The environment of the strait itself is the real killer. Hormuz isn't the open ocean. It's a jagged, rocky maze. And hidden within that maze is the IRGC's Mosquito fleet. Iran doesn't try to out-tech the US Navy with massive cruisers. Instead, they've mastered the art of quantity has a quality all its own. They operate hundreds of fast attack craft, small radar-evading speedboats that can clock in at over 60 knots. These aren't just boats, they are mobile, floating firing platforms packed with heavy machine guns, unguided rockets, and short-range missiles. They don't hide in the open sea, they lurk in the littorals, the shallow, cluttered waters near the coast where massive US destroyers struggle to see them against the background noise of the rocky shoreline. When the order is given, they launch in a 360-degree swarm. This is variable 2, the mousetrap. Imagine being the captain of a mine-hunting vessel. You are moving at 5 knots, your sonar is focused on the seafloor, and suddenly 40 speedboats emerge from the radar clutter of a nearby island. They aren't coming from one direction, they are surrounding you, zipping in close to blind your sensors and riddle your unarmored hull with holes. Even the best phalanx close-in weapon system has a saturation point. It can track and kill 10, maybe 15 targets, but while it's focused on the first dozen, the next 20 are already at point-blank range. It's a death by 1,000 cuts. And this leads us to variable 3, the incomplete equation. In any military operation, you need a roof to protect the workers on the floor. The Navy knows this, but the current solutions aren't adding up. A massive aircraft carrier is the ultimate roof, but it's too valuable to risk within the reach of Iranian coastal missiles. It stays hundreds of miles away in the standoff zone. From that distance, it can provide air cover, but it can't provide the constant, staring, low-altitude protection a minesweeper needs every second of the day. So why not use an Arleigh Burke-class destroyer? It has the Aegis combat system and incredible firepower. But a destroyer is a deep-draft ship. It's designed for the blue water of the Pacific, not the shallow, mine-infested brown water of the strait. If a destroyer enters the minefield to protect the sweepers, it becomes the biggest target in the room. If it hits one of those $1,500 mines, the US loses $2 billion in assets and a critical piece of its national prestige. It's a lopsided trade the Pentagon isn't willing to make. The result is a strategic void. The Navy is trying to mop a floor while the faucet is still running, and the ceiling is literally collapsing. You can clear 100 mines, but if you can't stop the speedboats from harassing your crews or laying new mines under the cover of darkness, you haven't solved anything. The mission never ends, and the risk only grows. The crews outside the strait are waiting because they know the current math doesn't work. They are solving an equation where the variables of vulnerability, swarm saturation, and lack of close-in protection haven't converged on a solution. Until now, to fix the math, you have to change the tools. You don't need a faster computer or a better laser. You need a weapon that can survive the swarm, ignore the missiles, and provide a permanent, terrifying roof over the minefields. You need something that doesn't care about a glass hull, because it isn't in the water. You need a machine designed specifically to survive the most intense kinetic environments ever conceived. You need a legend that was almost retired, only to realize that the world's most modern crisis requires the world's most resilient brawler. You need the A-10, and once you see how it integrates into the mine-clearing chain, you'll realize that the Warthog isn't just an old plane, it's the missing piece of the American Empire's most complex maritime puzzle. 1. So, if the high-tech Navy is paralyzed by a lopsided trade, risking a $2 billion destroyer against a $1,500 mine, 1. How do you break the stalemate? You don't do it with a more expensive laser or a stealthier drone. 1. You do it by introducing the one weapon the IRGC's Mosquito fleet was never designed to handle. You change the math by introducing the fourth variable into the equation. 1. The steel roof, and that roof comes in the form of a plane. The Pentagon tried to retire a dozen times. 1. Only to realize it is the only thing standing between a cleared strait and a global economic collapse. Meet the A-10 Warthog. 1. But we aren't talking about the A-10 as a tank buster in the deserts of Iraq. We are talking about the A-10 as the ultimate maritime brawler. 1. To understand why this plane is the aha moment for the Hormuz crisis, you have to look past its ugly, one utilitarian frame and look at its soul. It wasn't built for elegance. It was built for pure, unadulterated resilience. While the literal combat ship is an eggshell, the A-10 is a flying fortress. The pilot sits in what is essentially a 1,200-pound titanium bathtub, one capable of withstanding direct hits from 23mm armor-piercing shells. Its engines are tucked away high and back to protect them from ground fire. 1. And its flight controls are redundant. If the hydraulics fail, the pilot can switch to a mechanical manual reversion system and fly the thing home with nothing but wires and grit. 1. This is the resilience the Navy is missing. A shoulder-fired missile that would cripple an LCS or force a destroyer to retreat is 1 to an A-10, just another Tuesday. It can fly low, it can fly slow, and most importantly, it can stay. 1. This is the twist. In a minefield where speed is a liability and hanging around is a death sentence for a ship, 1. The A-10 turns the sky into a permanent fortified observation post. It provides the one thing the mine-hunting robots can't provide for themselves. 1. A 360-degree, staring eye that is too tough to kill. Now, let's talk about the tool that actually solves the swarm problem. 1. Nestled in the nose of the Warthog is the GAU-8 Avenger. It isn't just a gun. 1. It's a 7-barrel, hydraulically driven Gatling cannon that makes up about 16% of the plane's entire weight. 1. It fires 30mm depleted uranium rounds at a rate of 3,900 rounds per minute. That is 65 rounds every single second. 1. But here's the technical value that changes the logic of the strait. When the IRGC launches a swarm of 40 fast attack boats, 1. A destroyer's Aegis system is trying to solve a complex computational problem. Which missile to fire, which target to lock, 1. And how to reload fast enough to stop the 41st boat. The A-10 doesn't care about the 41st boat. 1. A single 2-second burst from the GAU-8 creates a cloud of kinetic energy that shreds fiberglass hulls like paper. 1. It doesn't need a $1 million missile lock. It uses ballistic math that is impossible to jam and even harder to evade. 1. Each 30mm round hits with enough force to disable a main battle tank. Against a speedboat, it's absolute overkill.
1-1 burst. One boat. Gone. The Warthog can engage 5, 6, 10 boats in a single pass, then circle back and do it again.
1. It doesn't run out of shots like a missile launcher does. It carries 1,100 rounds. 1. That is enough to wipe out an entire regional flotilla in one afternoon. But the real genius of the A-10 in Hormuz is the cost-exchange ratio. 1. Remember the Navy's nightmare math? A $1,500 mine versus a $2 million ship. The A-10 flips that script on its head. 1. An Iranian fast attack boat costs anywhere from $20,000 to $50,000 to build and crew. 1. A single 30mm round from an A-10 costs less than $100. Even if the pilot uses 50 rounds to ensure a kill, the trade is incredibly lopsided in favor of the US. For the first time in the history of the Hormuz blockade, the US has a weapon that is cheaper to use than the threat it is neutralizing. This is asymmetric attrition. By deploying the A-10 as a steel roof, the US forces Iran into the very position the Navy was in just days ago. If Iran sends more boats, they lose more money and more crews at a rate they cannot sustain. The Mosquito fleet isn't a swarm anymore, it's just target practice. This is the solution to the fourth variable. The A-10 provides the persistent, low-altitude protection that allows the Navy's mine hunters to work. Imagine the scene. A Seahawk helicopter is hovering, using its laser to map the water. Below it, an unmanned robot boat is towing sonar to find bottom mines. Normally, they would be sitting ducks. But 500 feet above them, a pair of A-10s are circling like sharks. When they see the mobile missile launchers rolling out of the mountain tunnels, they see the speedboats staging in the coastal coves. And the moment those threats move, they are met with a burst that echoes off the cliffs of the strait. The A-10 Warthog solves what the Navy couldn't, because it doesn't try to outcalculate the threat, it simply outlasts it. It removes the fear of the swarm, which in turn removes the market force that closes the strait. When the insurance companies see a permanent, indestructible roof over the shipping lanes, the risk premiums drop. When the tanker captains see the Warthog circling, the fear evaporates. The Navy solves equations, and for months. The equation for Hormuz was unsolvable because it was missing a piece that could survive the roof problem. By pulling a legendary brawler out of the history books and placing it over the world's most volatile choke point. The US didn't just find a way to clear the mines. They found a way to make the mines irrelevant. Because a mine only works if the enemy is afraid to look for it. And with a titanium-plated monster standing guard, the US Navy isn't afraid to look anymore. The faucet is shut, the floor is being mopped, and the roof is made of steel. Now, all that's left is for the world to watch how this equation finally reaches its optimal end. The United States Navy doesn't just win because they have the most expensive lasers or the stealthiest drones. They win because they are masters of the equation. And in the volatile environment of the Strait of Hormuz, they realize that a multi-billion-dollar fleet is only as effective as the environment it operates in. The A-10 Warthog isn't a relic of a bygone era. It was simply a solution waiting for a problem difficult enough to require its specific brand of resilience. In the chaos of modern warfare, we often assume that the newest tool is always the best. But Hormuz proves the opposite. Sometimes, the most sophisticated technology on Earth is only made possible by the presence of the most reliable, low-tech brawler ever built. By placing a titanium-plated monster over the shipping lanes, the Navy didn't just counter the swarm, they changed the psychological landscape of the entire region. With the Warthog establishing that permanent steel roof, the specialized mine hunters can finally do what they were built to do, without the fear of being deleted by a cheap speedboat or a coastal missile. The variables have converged. The faucet is shut, the roof is in position, and the equation for a secure strait has finally reached its optimum. The era of the $1,500 mine holding the world's economy hostage is coming to an end. Not because the mines went away, but because the United States found the one piece of the puzzle that made them irrelevant. The math is clear, the threat is neutralized, and the strait is open on American terms and American timing. We make original videos from scratch, analyzed and animated by humans,